All right, you've survived the worst of it for this week. Loans will be pretty spicy too, but we're going to talk about payout annuities. And it's almost the same as the last video. Okay, it's almost the same as annuities. It's slightly different. So annuities is I'm depositing every month into an account. And every month I'm depositing, every month it's getting interest, every month it's growing exponentially. And eventually I will have saved my target goal, hopefully. Payout annuities are the opposite. It's the reverse. It's okay, well, now I want to retire, so I'm going to now withdraw every month. And I'm still making interest. I'm still making interest on the account. But now every month, instead of putting in, I'm now taking out. Okay? And that's what this video is going to be about. And then, at the end, you've taken out everything. So it's just growing exponentially, and now it's kind of decaying the other way, but still a weird kind of decay. Anyway, we're not going to talk about graphs today. Add that to the list of things I'm not going to talk about because there's so much fun math to talk about. So the formula is very similar. This is not the same, but it's very similar to the annuity formula, our payout annuity, as we're withdrawing after our, say, retirement. And so we'll be using this formula. It'll be very similar. All the letters mean the same things as before, but now we have a 1 minus instead of a 1 plus. I think it was a 1 plus. I don't remember the formula off the top of my head. So now we used to have a something minus 1. Now we have a 1 minus something. We also have a negative in our exponent now. Okay, so let's do 2 examples and then move on to the homework video. Uncle Moneybags wants to be able to withdraw $10,000 per month. Whoa. Yeah, Uncle Moneybags is living large. 10 grand a month sounds like a nice income. He wants to be able to withdraw $10,000 per month for 35 years after retirement. He's retiring early too. How much will he need in the account if it's earning 6.5% interest rate when he retires? How much does he need in his retirement account to be able to have this standard of living? It's going to be a lot, but they don't call him Uncle Moneybags for nothing. So first things first, this is a payout annuity. We're withdrawing every month from something that's earning interest. So we look at this formula and we're going to copy it down. Payout annuity. P naught is D times 1 minus 1 plus R over K to the negative NK divided by R over K. And now we replace each of these with their values. D is it used to be our monthly payments. Well, now it's going to be our monthly withdrawal. So he's doing $10,000 a month. 1 minus, parentheses 1 plus. The interest rate is 6.5%. And especially when there's decimals, be careful. Move it 2 to the right. That's going to be 0.065. Divided by, he's doing it every month. 12 months in a year, K equals 12. There's a negative in the exponent now, and we have 35 years, and K is still 12. All of that is divided by R, our interest rate, 0.065 still, divided by K, which is still 12. And this is what needs to get calculated. Just like before, we're going to go to Desmos. We're going to type it in almost exactly like we see it here. We're going to add parentheses in this exponent. You want to write parentheses here, you can, because this is exactly what we're going to type. And then just use the asterisk for multiplication, tab to get out of the denominator or the exponent, and caret for the exponent. Shift 6 for that caret. Let's do it over here. This bar up here was our annuities formula. This bar down here is going to be our payout annuities formula. 10,000, parenthesis, 1 minus, parenthesis, 1 plus. 0.065 / 12. Tab out of the denominator, parenthesis, caret, whoa, caret, that's shift 6, parenthesis, negative 35 times 12. Use an asterisk for that multiplication. Tab out of the exponent, parenthesis, and that all gets divided by parenthesis, 0.065 / 12, tab, parenthesis. That's a big number. I said if you want to live off of 10 grand, you live in 10 grand a month for 35 years, you're going to need a lot of money in that retirement account. Okay. Let's copy that number down and round to the nearest cent. That is going to be approximately 1,655. That's $1 million, $655,206.25. Uncle Moneybags. That's a nice looking retirement account if you can get that. All right. And that's example 7.8. So it's all just plugging things in, typing things in. Let's do another one. Another algebra one, 7.9. Professor Smart has saved $500,000 for retirement. So again, it's already turning the problem on its head. Now we know that there's $500,000 available. That's that P0. And the question is, if he set up a payout annuity for 30 years in an account paying 10% annual interest, how much could he get every month? So now it's right. This is our D value. Oh, that was a little better. So this is what we have right here. So let's write down the formula again. P0 is equal to D times 1 minus 1 plus R over K, because we're withdrawing negative NK right now, end parentheses, divided by R over K. But now this D is the thing we need to find. And we know everything else. P0, this is the amount that's saved for retirement. That's 500K. D, we don't know this yet, so leave it as a D, times 1 minus 1 plus. Professor Smart has a 10% interest rate, still doing monthly payments, and we have 30 years, still doing monthly. Divided by the interest rate, 0.1, divided by still doing monthly. And we have to do the exact same process as before, just with a slightly different formula. We need to solve for D. So let's simplify the right-hand side a little bit. Let's get some approximations. Let's type in the numerator, just like we did before. And maybe we're going to want to save this payout annuities. Maybe we'll go down to 3. We can save the payout annuities formula if we want to use that in the homework video. So we're going to type in that numerator. We type it in parenthesis 1 minus parenthesis 1 plus 0.1 fraction 12 tab parenthesis negative 30 times 12, like so. That is our numerator. And again, give us a lot of digits, 0.9495902. That should be enough. And then we also need the denominator, which was 0.1 divided by 12. Ugh. 0.0083 with the 3 repeating. So just like before, to solve for D, we multiply both sides of the equation by the reciprocal. And this is a fraction divided by 1 if you'd like. So multiply this by the reciprocal is 0.0083. 3 is repeating. 0.9495902. That cancels with that. That cancels with that. But what we do to the right-hand side, we also have to do to the left. 0.0083, the 3 is repeating, divided by 0.9495902. Multiply this out on the left-hand side, and we will have our monthly withdrawal. So we type in this left-hand side into our calculator, and let's see what we get. 0.0083. The 3 repeats, so let's just put a bunch of 3s. Divided by 0.9495902. Tab out. Multiply that by 500,000. Divided by 1. You're going to get that D is 4,387.86. So Uncle Moneybags needed 1.6 million so he could live off of 10 grand a month. Professor Smart only has 500K only and is living off of 4.4 grand a month when he retires. Okay? So this much per month is what they'll be able to withdraw from the account. And that's kind of how we do it. And again, one of the advantages to using something like Desmos is if I wanted to do another payout annuities problem, I already typed this in. I can just change the numbers I need to change. If I need to do another annuities problem, I already typed this in. Can save it, or you can get rid of it with the X. The next video, we're going to do some homework problems, and we will be doing precisely that. Okay? Good luck, and let me know if you have questions.